Lesson 3.2, Solving Linear Equations by Graphing. In this video, you will learn to solve linear equations by graphing and estimate solutions to linear equations by graphing. So vocabulary is linear function, parent function, family of graphs, root, and zero. Okay, so we want to look at a parent function. This is a parent function of the graph of a line, a linear function. So the parent function is the basic graph. So before you do anything to it, so like before, if you have the function f of x equals x, this is the graph of f of x equals x. So if you were to add 3 to that, it would no longer be a parent function. It would tell you what you're doing to the parent graph. That plus 3 does something to the parent graph. In this case, it shifts everything up 3 and it would be up here, but we'll talk about that at some other time. Okay, so for the parent function of this f of x equals x, the domain is all real numbers and the range is also all real numbers. So there's any value of x can be defined in any value of y. So if I want to use graphing to solve an equation with one root, there's 2 ways you can do it. You can do it, one, algebraically, which is what we're going to focus on. Algebraically, I don't know how you spell that. Okay, but if we use algebraically, we're going to solve this like we would solve any other one. So we want to get x by itself. So if we have 1/2 x plus 3, first thing I'm going to do is subtract 3 from both sides because I want to get rid of that plus 3. So I get negative 3 equals 1/2 x. Okay, and to get rid of that 1/2, I'm going to multiply by the reciprocal, 2 over 1, or just 2 to both sides. And I get negative 6 equals x. So x equals negative 6. So you can solve these algebraically. On B, we're going to focus on solving it graphically. So to solve it graphically, I want to get everything onto one side. So that means I want to get rid of this 2 so that it's on the same side as everything else. So I'm going to do minus 2. Basically, I want to get 0 on one side. So this becomes 0 equals 1/3 x plus 1. So I'm going to treat this as if it's the function f of x equals 1/3 x plus 1. And I'm going to graph this part right here, like we were graphing in the last section. So I can make a table of values. So I'm going to pick x values and see what I get for y. So if I put in 3, and I'm doing 1/3 x plus 1, that's going to be 1/3 times 3 plus 1. And that's going to give me a y value. So my y value here is going to be 1/3 of 3 is 1 plus 1 is 2. Okay, if I put in something like 6, or let's do negative 3. So 1/3 times negative 3 plus 1. So I get negative 1 plus 1 is 0. So I get negative 3, 0 as a point. So right there. And I get 3, 2 as a point. And then I graph these. So this goes like that. And that goes like that. And the solution to this equation is where it touches the x-axis. So this is the x-axis. So where the graph touches it, it touches at negative 3. So that means x is negative 3. So that's how you can solve this equation using graphing. Get 0 on one side, graph it, and where it touches the x-axis is your solution. Okay. So again, we're going to do this with 2 methods. The first one we're going to do algebraically. So 2x plus 5 equals 2x plus 3. In order to solve this, I would want to get my variables together. So I would subtract 2x, but they cancel on each side and you get 5 equals 3, which means there's no solution. So that's doing it algebraically. So graphically, if we were going to solve a similar problem, I want to get everything onto one side. So if I were to do that, I have 5x minus 7 equals 5x plus 2. So if this is minus 7, I'm going to add 7 to both sides. I get 5x equals 5x plus 9. And I want to get my 5's on the same side too. So I'm going to get rid of that by doing that. And I get 0 equals 9. So that means I'm going to graph it. Oops, sorry. I'm going to graph it as if it was f of x equals 9, which is just a vertical line at 9. Sorry, I didn't put the graph up there. So 9 would be like up here. So is that line ever going to touch the x-axis? No. So if you've got a line at the end that doesn't touch the x-axis, it means no solution. Wow, what's going on with this thing? Okay. All right. Kendra's class is selling greeting cards to raise money for new soccer equipment. They paid $115 for the cards, and they are selling each card for $175 times each card. Oh, they gave us the equation. Okay. Y equals 175, x minus 115. Okay. So that represents the profit. So I want to find the zeros of the function. So remember, we can find the 0. 0 is another word for the solution. So solution, 0 are the same thing. So that's when it's going to touch the x-axis. Okay. So I want to graph this. So I'm going to make a table of values, x and y. So if I put in 75 for x, 75 times 1.75 minus 115 is 1.75 times 75 minus 115. I get 16.25. So I'm going to graph that point. So 75 is going to be about here, and 16.25 is going to be in here somewhere. Okay, and I'm going to put in another point because to graph a line you need at least 2 points. So 1.75 times 100 minus 115, and you get 60. So I have the point 160. So that's right there. If I were to draw a line through my 2 points, I want to know where it touches the x-axis. So if this is like my x-axis, right about there should be my solution. So I can say that they're going to sell 65 greeting cards in order to make a profit. So 65 cards. Okay. And that is this section. I will scroll through the problems at the back, and if you feel like doing them, great.